Good evening, everyone. This is Unit 1 of IAL Physics, May 2016. In the first question, which of the following is equivalent to joules in terms of SI base unit? So we know joules is a unit of energy, and we know work done, which is equals to force into distance, equal to Newton meter, or we also say joules. So basically, joules is equivalent to Newton meter. And what about Newton? We know F is equals to ma. So unit of mass is kilogram and unit of acceleration is meter per second square. So kilogram meter per second square is equivalent to Newton. So in place of Newton, we can write kilogram meter per second square, and that is multiplied by meter. So it will turn out to be kilogram meter square by seconds. And if we move this in numerator, so it will be kilogram meter square second minus 2. A wind turbine generates 550 watts of electrical power for an average 7 hours each day. What is the total energy in megajoules? So energy is power multiplied by time, but to get the answer in joule, time should be in seconds. And power is in watt, which is joules per second. So power is 550 multiplied by time, which is 7 hours, but we have to convert into second. So multiplied by 60 and 60, so it will be 550 times 7 times 60 and 60, which is equals to 13860. And if we convert into mega, so we have a point here 1 2 3 4 5 6, so it will come out as 13.8 into 10 to the power 6 joules. And 13.8, if we round it off, it will be 14. So it will be 14 into 10 to the power 6 joules, and 10 to the power 6 is mega, so it is equal to 14 megajoule. That's why B is the right answer. A student applied a range of forces at the end of a copper wire and measured the corresponding new lengths. The force extension graph is shown. What would be the maximum force that applied and then removed so the wires can go back? So within the elastic limit, the object will return back to same position. So till this point, the line appeared to be straight, and the value of the force is 400. That's why C is the right answer for question 3. Then what is the elastic strain energy stored when it is extended by 4 millimeter? So energy stored, that is equals to area under the graph. So in this case, it is making a triangle. So it will be half base into height. So it will be 1 by 2. The base is 4, but that is in millimeters, so we have to convert into meter. So 4 into 10 to the power minus 3 multiplied by height, that's equal to 400. So 400 times 4 divided by 1000, and that divided by 2, so which is equals to 0.8 joules, which is A. So A is the right answer for question 4. The displacement time graph for an object is shown. Which of the following is corresponding velocity time graph? So displacement time graph, the slope represents the velocity. So slope is representing a velocity. We divide this graph into two parts. Example A, B and C. So from A to B, what is happening? The slope is decreasing. So from A to B, slope is decreasing. It means the velocity should decrease. And what about the value of the velocity? Whether the slope is positive or negative. So when we check y1 and y2, so y2 is above y1, so it means it will be positive. So velocity should decrease and in a positive axis. So which one is showing a velocity is decreasing in a positive axis? So D. And what about from B to C? From B to C, when we check the slope, the angle with x-axis, that is increasing. So slope is increasing. So velocity is increasing, but what about the value? When we check y1 and y2, so you will find that y2 is below y1, so it is negative. So velocity should increase in negative axis. That's why D is the right answer. For question 6, the picture is hung using a wire placed over a small hole as shown. T1 and T2 are the tensions. So this one is T1. We need a resultant. Then from tail of the first, from the head of the first, we draw the second vector. That's T2. So one is T1 and then we have T2. And the resultant is from tail of the first to the head of the last. When we join, this will be a resultant, which is T. So it matches with option D. A ball of mass m fall through a height h. What is the kinetic energy? Halfway. Because the potential energy changes to kinetic energy at the maximum height, it will have potential energy, and at just before hitting, all the potential changes to kinetic. So in between, the kinetic energy will be half of the potential energy. And potential energy is mgh, so mgh divided by 2. For question 8, a car travel at a speed of 20 meter per second due east and then turn around and travel at a speed of 40 meter per second west. Taking the direction due east as positive, which is the correct answer? So due east is positive and due west, so west will be opposite, so it will be negative. When we are checking a change in speed, because speed is a scalar quantity, so it's just a change difference in the value, we don't have to consider the sign. So 40 minus 20, that is equals to 20. What about change in velocity? Final minus initial. Final is minus 40 minus initial is plus 20, so when we solve it will come out as minus 60. So change in velocity is minus 60, but change in speed is only 20. That's why A is the right answer. A football is kicked across the pitch with initial vertical component of velocity is u. So we know the vertical component, it is launched with certain angle, and the vertical component of the velocity is known, that is u. What is the equation used to determine the total time of the flight? So first we'll find the time to reach the maximum height, and the total time will be double of this. So at maximum height, the vertical velocity will be final vertical velocity will be 0. So we have the formula V is equals to U plus AT. V is 0, U acceleration is due to gravity, so minus G and T. So it will be U minus U is equals to minus GT, or U divided by G is equals to T. But that is a time for half to reach the maximum height. Then it will be twice, because the total time will be 2T. So it will be 2 U divided by G. So it will be D is the right answer. For question 10, a ball was placed on top of a compressed spring. When the spring is released, the ball accelerated upward. If this were to be repeated on moon, the acceleration of a ball, so if spring is compressed to the same length, then it means it stored the same amount of energy. So here the elastic strain energy is converted into kinetic energy. And what happened if this was repeated on the moon? The acceleration of a ball would be greater, because what will happen, because it's having a smaller weight, so, or acceleration due to gravity, so the force which is opposing its motion is smaller. That's why resultant force is higher, or it will have a greater acceleration. So acceleration will be greater because its weight is smaller, the downward force smaller. That's why it will have a greater acceleration. So this was Unit 1 of IAL Physics from June 2016.